Welcome back to the final and third screencast. So in this screencast, we're going to talk a little bit more about soil profiles, and I'll show you some examples of them. Before, though, I'm going to show you and talk about what soil texture and structure is. We're going to talk a lot more about that later on in the quarter, so I'm just going to briefly define it here, and then we'll talk about how we infer a soil's age from looking at a soil profile, which does not necessarily mean we're looking at and trying to understand the soil's chronological age. So what is soil texture? Soil texture, the definition for that is the percentage of sand, silt, and clay in a soil. And sand, silt, and clay are defined by how big they are. So that's just particle size. And so you can see the big sort of oval is in relation to the others is how big sand is. And from one side of that piece of sand to the other, that's about 1 millimeter in diameter, and your thumbnail is about the same. So if you look at your thumbnail, and you look at, like the thickness of it, that's 1 millimeter. Silt, is much smaller than that, and clay is just those little dots there. So let me ask you this. If you had 1 gram of sand and 1 gram of silt and 1 gram of clay, which one should have the greatest specific surface area? Think about it. You say clay? You're right, right? So if clay has the greatest specific surface area, it's going to react the most with its environment. It's going to react the most with water and with gases and with nutrients relative to silt and sand. So the percent of sand, silt, and clay that's in the soil allows us to use this tool right here. It's called the textural triangle, and classify a soil into one of 12 textural classes. You can see on the left there's where our sandy soils are found. So those are ones that have a high percentage of sand. On the right axis, we have silt, right? And so the soils that are mostly silty, right, are on the right side. And then the clay ones are kind of towards the top of the diagram. And the more clay that's in the soil, the higher the specific surface area of that soil, the higher the reactivity, etc. And we'll talk much more about this later. Now, the way that sand, silt, and clay come together to form a shape, that's called soil structure. So there's several different soil structure classifications. And again, that's just the arrangement of soil particles, sand, silt, and clay into very distinct shapes, right? And each of these distinct shapes has a classification associated with it, and also has properties that impact the movement of water through them, the movement of air, gases, and plant roots as well. So let's talk about soil profiles. So we talked about soil profiles before when I defined it, and I just said soil scientists trying to understand soils from kind of a depth perspective. So looking at a soil from a three-dimensional perspective from the ground surface downward. And when you do this, you will generally always see different layers. So the different layers of soil here, we got that O layer, the A layer, the B layer, the C layer. Those are called horizons. And the horizons just have different properties associated with them. And they're given these specific letters or designations. And we'll talk about how we do that later. So how do we tell how old the soil is? Well, we tell it by looking at a soil profile. So I'm going to show you a couple examples of soil profiles, and then we'll talk about how we can use the horizons that are in a soil profile to get an idea of how old that soil is. And by old, we mean how developed or weathered that soil is. So here is a grassland soil, and you can see that we got some topsoil layers that are designated with A, and then as we move down, the soil gets lighter. Here is a desert soil. You can see that it looks quite a bit different because there's been much less water that's moved through it. Here is a wetland soil, and a wetland soil is formed almost entirely of organic matter, and the O horizon designation means organic, as you probably figured out already. Here is a subtropical or semi-tropical soil, and you can see that it looks much different than that grassland soil, in that this soil is much redder, where the other one was much more tan. And that red is associated with what element from the periodic table do you think? Iron. That's right. Good job. So here is a soil that you might find in the southeast of the United States, or the Pacific Northwest, or even the northeast of the United States. This is a pine forest soil. And you can see that in the topsoil, we got some organic colors, and then we got that kind of white powder sugar colored soil layer. It has that tongue kind of going down right here, which is crazy. And then we have this other dark colored layer that's labeled with BH. We'll get into what that means later on. But you can see that these soils are really different from each other. And here would be a pretty young soil developing on bedrock. So this white stuff down here is bedrock, and then we have a pretty shallow soil here, and then another soil layer here. And then here is probably my favorite soil. This is a highly weathered tropical soil. And highly weathered just means that it's had a lot of rain that's moved through it, and it's changed it and removed pretty much everything out of that soil except for, what element do you think mostly? Iron, right? Iron causes things to be red. So this is a highly weathered, humid, tropical, equatorial soil here. So how do we tell how old the soil is from looking at its profile? The way that we do that is by looking at the number of different horizons, right? And that's the O, A, B, and C layers there, and how deep they are. So the more of those, and this is in general, the more of those that we have, and the thicker they are, the older a soil is. So if we take this picture here of a landscape where you're looking at the top of the hill towards the left, and then the sloping part kind of in the middle, and then the bottom of that soil on the right, or the bottom of that landscape on the right, you can see that at the top we have a much more developed soil than we do in the middle. Right at the top, you got those 3 layers, and they're pretty thick soil layers, whereas in the middle we have much thinner layers. And the reason for that is because the top is a stable location, and in the middle we had an area that's prone to erosion because it's in a steep area, so it just isn't going to develop as deep soil layers and as thick as soil layers as up above or down below. And then below, right at the bottom land, that's a place where soil is going to accumulate, and also water is going to accumulate. So the more water that's moving through the soil in general, the more that soil is going to develop into distinct layers. So the top and the bottom, right, is where we have our older soils, right? And in the middle is where we have our youngest soil. Here is what a very young soil would look like. You've seen this one before. And here is what an old soil would look like, a relatively mature soil. You can see that BT layer right there is pretty thick, right? It's pretty deep. And then we have an A horizon, an E horizon, this thick BT horizon, and then this C layer right here, which is also pretty thick. But the more different soil layers that we have, and the thicker the soil layer, the older that soil is from a development perspective. And so if we look at Florida state soil, right? So we're looking at a soil profile for Florida state soil. It's called Myakka. How many soil layers do you see here? Did you say 4? Right? So we got the topsoil, we got this white kind of soil layer here, and then this darker one, and then we kind of, looks like we get into some rock or a rocky layer down here. So we got 4 soil layers there. And then if we look at this question right here, right, which of these soils is the oldest and why, do you think? Pretty tough question, huh? Well, it might not be exactly evident, but if you said, wait for it, if you said C, you're right. And the reason for that is because we have more different kinds of soil layers here than we do in the other examples. Here we have an A and a B and a C, and the lowercase letters just give us a little more information about the soil. We'll talk about what that means later in the course. And here we have kind of the same idea. We got an A, we got 2 B's, and then a C. But over here, right, we got an A and an E, and then a B, and then a C. The B's thick, but we have more different kinds of layers over here than we do in these other 2 examples. So that's it for the screencast. There'll be some quiz questions on PolyLearn associated with these 3 screencasts. And you're welcome to go back and view these screencasts as many times